Hello students, welcome back. Hope you are doing good. So let's get started with our exercise with chapter 8.3. So in this particular exercise, we need to remember some of the formulas which would be used. So let me just jot down here to solve this exercise. So we have the formulas like this. I'll just write it down. Okay, so please remember this formula for solving this exercise. Cos square A plus sin square A is equal to 1. 1 plus tan square A is equal to secant square A. Cot square A plus 1 is equal to cosecant square A. So these formulas will be utilized in the entire exercise to solve this trigonometric exercise. Okay, so as we proceed, we'll talk about in detail how we can utilize, and also some of the identities like sin A, it's inverse of cosec A, tan A is inverse of cot A. So let's start our first question. What it says is express the trigonometric ratios sin A, secant A, sin A, secant A, tan A in terms of cot. So we need to express this three given ratios in terms of cot A. So let's start with our sin A. So sin A, let's express, we have the identity sin A is equal to inverse of cosecant A. So let's put it here, cosecant A. Okay, so the reason why I put it here is we want to utilize the formula of this. So what we have to do is we need to convert this in terms of cot. So if you see in this formula list, what is that which can be equivalent to cot? So we have cot square A plus 1 which is equal to cosecant square A. So that's why I have taken this, and we know sin can be represented to inverse of cosecant A. So here if we want to utilize this formula, we are seeing here it need to be squared. So how we can get this squared? By squaring both sides. Okay, so this can be represented as root of cosecant square A. Square get cancelled, still it remains the same. So it is cosecant A. Okay, so now how can we represent here? So by replacing this formula by root of cosecant square can be represented as with this formula. Okay, cot square A plus 1. So our sin A can be represented in this form of cot. Are these clear, students? Okay, so let's move to our next secant A. So let's try to represent our secant A in terms of cot A. Okay, so let me just put it down here. So here, looking at this formula, we can see that secant square can be represented in this form, 1 plus tan square A, which can be further converted into cot. So we cannot utilize the first, we cannot utilize the third. So we can utilize this particular formula to convert it. So secant. Okay, so if you see here, it is saying secant square. Okay, so secant square, so let's put it here, the secant square of A is equal to 1 plus tan square A. So this nearby. Okay, so we wanted the secant square. So squaring both the sides, we can take the root. Okay, so if you put the root here, the square goes here. So it will be represented as 1 plus tan square A. So this is something like you have A square. Okay. This is something represented like this. Okay. So we have A square. We have A square. So square gets cancelled here. Okay. So this is clear. This is how we have done. So we wanted the without the square. So what we did was we put the right side, the square, it gets cancelled. Okay, so further simplifying this, secant a is equal to root of, so this root, so we can divide the root here, root of cot square a plus 1 square, and root gets cancelled, it becomes cot a. Okay, this is our secant a. Okay, hope this is clear. So now we need to find tan a in terms of cot. So let's move it further. So tan can be represented as inverse of cot. So this is the identity which we can use, 1 by cot A. Okay, so this has been represented, sin A is represented as in terms of cot, secant A is sec A is represented in terms of cot, tan is represented in terms of cot. Okay, so we have solved the first question which was being asked. So we need to come with the trigonometric ratios given sin A, secant A, tan A in terms of cot. So remember, these are the formulas which we can utilize, and these are the identities which we can utilize to solve this problem. Okay. With this, let's move to the next question, students. Write all the other trigonometric ratios of triangle A in terms of secant A. Okay. So we need to find all the trigonometric ratios in terms of secant A. Okay. Okay, so what are the trigonometric ratios we have? We have, we have sin A, cos A, tan A, cot A, cosecant A, and secant A. So secant A we need to express in terms of secant A. So this is being asked. So all the other trigonometric ratios, these are the trigonometric ratios. We have 6, 1, 2, 3, 4, 5, and the secant including this becomes 6. So secant is we need to express in the terms of secant A. So this 5 we need to put in terms of secant A. So this ratios. Let's proceed with the sin A. So please remember the formulas which we have used in the first exercise. This will be, so the first question, this will be utilized in the entire exercise. Okay, so note it down in a piece of paper so that you can recall, write it down. So once you write it 2-3 times, you should be able to remember it. Okay, so these are the ones which will be helpful in solving the trigonometric ratios. Okay, so sin A. So sin A, we have the formula sin square. Okay, so for sin, let's solve it for sin. So we have a formula sin square A plus cos square A is equal to 1. Okay, so let's bring the sin square A and bring all the terms towards right side. So it becomes 1 minus cos square A. Okay, so this is in terms of square, so we need without this square, so we can bring this square towards right side, becomes root. It becomes root of 1 minus cos square A. Okay, so here, okay, so squaring both sides, you can say, or you can square. This was 2, right? So this squaring both sides. So this becomes your sin A. Okay, so we know that cos square can be represented with the identity cos A. Okay, so it can be represented with the identity as cos A is equal to 1 by secant A. Okay, so remember this identity. So let's utilize this identity over here. 1 minus of 1 by secant A. So here there is a square, so we need to put this square here. Okay, so let's try to find the LCM here. Secant square. Okay, so secant square A minus of 1. Okay, So sine A. So let's further solve it. So let's divide okay, root of this. Okay, so this can be represented as root of A by B can be represented as root of A divided by root of B. So this is what we will utilize here. Okay, so secant square A minus 1, then further root of secant square A. Square root gets cancelled. So it becomes sine A in terms of secant square A minus 1 divided by secant A. So this is how we have represented this sine into secant terms. Okay, so let's move to our next issue, conversion. Let's do it here, cos A. Cos A. Okay, so we have seen the cos A can be represented as 1 by secant A. So this is what has been asked, so we need to convert this cos to secant A. So this we can utilize it. Okay, so these are secant. Okay, so let's convert the third, which is tan. Okay, so tan A. Tan A. Okay, so we have the formula for tan A. Tan A can be represented as 1 plus tan square A equivalent secant square A. So this formula we can utilize. This we have discussed in our first question. Okay, so remember this formula. So let's utilize this formula for converting tan into secant format. Okay, so 1 plus tan square A is equal to secant square A. Okay, so let's simplify it further. Let's put the tan square A is equal to secant square A. Let's bring this 1 toward this side, it becomes minus 1. Okay, so we want in terms of not in terms of square, so squaring both the side, or you can say if there is square you can put a root here. Okay, so simplifying this, tan A is equal to this, if you remove square here it's root towards the right side, so it becomes secant square A minus 1. Okay, so let's move forward. Okay, so let's solve the tan. Tan is done. Okay, let's highlight it here. Tan is done. Okay, let's solve cot. Okay, cot. So you know how is cot? Cot is nothing but the reverse of tan. Tan A. So we have solved only tan A, so we can put the expression in this here, cot A. Cot A is equal to, so tan value we can put it, which is in terms of secant square A minus 1. So we got the value of cot. Okay, so what is next? Next is cosecant. Okay, so what is cosecant? We know what is cosecant. Cosecant is nothing but, okay, cosec A is equivalent to reverse of sin A. Okay, so remember this. So we have already found the sin A, so it is reverse of sin A. So we can put it something like this. Reverse, if you do sin, so reverse. Okay, so either you can represent this 1 by sin A's detail, or you can reverse it since it's this one. So you can put it as secant A divided by root of secant square A minus 1. Okay. Okay, students, so we have got sine, we have got tan, we have got cot, we have got cosecant. Okay, also we have cos. Okay, so with this we have completed this question. what is being asked here: sine, cos, tan, cot, cosec in terms of secant A. So one thing to remember here is the three formulas: sine square theta plus cos square theta is equal to 1. Then we have 1 plus tan square theta is equal to secant square A. Then we have third formula, cot square theta plus 1 is equal to cosecant square theta. Okay, so this formulas will be utilized for trigonometry exercise solving. Okay, so remember this formulas. This will be utilized as we move forward in the next examples as well. Okay, let's move to the next question, students. Okay, so choose the correct option justifying your choice. So we have been given the options here, and which one is the right answer we need to find here. So let's get started with our question here. So it says, okay, so 9 6 square A minus 9 tan square A. Okay, so with this we can get started. Okay, so 9 is common here, so let's bring the 9 outside. Secant square A minus tan square A. Okay, so students, we have we know the formula, one of the formula where we have tan and secant. So 1 plus tan square A is equal to secant square A. So here let's utilize this formula. Okay, so let's see how we can correlate here. So tan square. So let's bring this let p1 here. Okay, so secant square remaining here. Then this tan, if you bring it toward this side, it becomes minus tan square A. So if you see here, we can correlate this with this particular and replace, so its value will be 1. So 9 into 1 by using this formula. So it becomes 9 into 1 is 9. Okay, so the answer is B, 9. So students, so one thing to be here is to be identified is the formula to be identified, how we can convert this. So basically trigonometry, most of the times this is the one which will be utilized for solving the exercises. Okay, so remember this formula: 1 plus tan square is equal to secant square A, where we can see that the secant and tans are available. Hope this is clear, students. Let's move to the next question, sub part of the question. Okay, students, so here the expression is given here: 1 plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta is equal to 0. So once one hint what I would give is, once this sort of question comes, try to put it in terms of sine and cos, which will help in simplifying. So remember this, whenever you see something tan, secant, cot, cosecant, we can utilize in terms of the sine and cos. Okay, we know what is tan. Okay, let's try to simplify it. Okay, so we have a formula. It's not formula, what I can say is, let's put the question here: 1 plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta. Okay, the reason why we have put is, so the formulas which we have, three formulas, we cannot put those. So the best way option would be to trying to simplify this. How do you simplify? You can utilize the sine and cos, converting into sine and cos. So can this be converted? Yes, tan can be converted. It is sine by cos is tan. Okay, secant is reverse of cos. Okay, cot is nothing but the reverse of tan. Tan, it can be represented as cos by sine, or it can be reverse of tan. Okay, so cosecant. So cosecant is nothing but the reverse of sine. So with this way we will get the sine and cos, so we can utilize this further. So let's simplify it. 1 plus tan can be represented as sine theta by cos theta, plus secant theta can be represented as 1 by cos theta. One plus cot can be represented as cos theta by sin theta, which is nothing but the reverse of tan theta. minus cosecant. Cosecant is nothing but the reverse of sine theta. Okay students, any confusion till here? This conversion from the first step to second step. Tan represented as sine by cos, secant can be represented as 1 by cos, cot can be represented as cos theta by sin theta, cosecant can be represented as reverse of sin theta. Okay, so further let's try to solve it. Okay, so we can take the LCM in this cos theta. Okay, so it will be cos theta plus remaining sin theta, cos theta is already plus 1. Okay, so here also let's take the LCM. Sin theta plus cos theta minus 1. Okay, so further simplifying we get the value. Okay, so we can see that cos theta plus sin theta plus 1, sin theta plus cos theta minus 1. This is something being represented as so this is the common, you can say. Okay, so this can be represented as a plus b into a minus b, right? So let's consider a as cos theta plus sin theta and b as 1, so it can be represented this way. Okay, so here if you can see a as sin theta plus cos theta and b as 1, so we can replace this formula using this formula. Okay, so it will be something like this: a squared minus b squared. Hope this is clear, student. So we are going to convert this in this format. Okay, so what is a is nothing but cos theta plus sin theta, okay, whole square. These are a, then minus sign of this. Okay, then we need to put the b square. What is b here? B is 1. Okay, so if this clear, students? If not, just see this polynomial expressions. Okay, a plus b into a minus b can be represented as a square minus b square. Okay, so now the base. Okay, so this gets multiplied cos theta into sin theta. Okay, so let me repeat it here. We got one expression which can be represented in this format, so we converted that into this and replaced here. So the reason why we have done is this can be put into the formula. So let's try to see how we can further simplify and utilize. So eventually in this trigonometry we need to see it should fit in one of the formulas. So to fit in the formulas we need to start converting into the forms which is required. So let's see how this proceeds. Okay, so we have certain formulas, right? Cos square theta plus sin square theta is equal to 1. So now something similar we can put it here. So let's try to simplify it further. So here we can see that it is in the form of a plus b whole square. Okay, so we know the formula. What is a plus b whole square? It can be represented as a square plus b square plus 2ab. Okay, so let's put in this format: cos square theta plus sin square theta. Okay, so a is here cos, b is here sin. Okay, so plus 2, based on this formula 2, we need to multiply cos theta into sin theta. Okay, so this is the then okay, so we have substitute this in this formula. So the minus sign is there, then we have 1 square is 1. So then base we have cos theta into sin theta. Okay, so we know there is one formula: cos square theta plus sin square theta is equal to 1. So we can replace that Okay, let me write it down here. Cos square theta plus sin square theta is equal to 1. So we can see here, we can replace this value. Okay, its value is 1 plus 2 cos theta into sin theta minus 1 divided by cos theta into sin theta. So if you can see, plus 1 minus 1 get cancelled, and here if you can see, there is a, okay, so here we have, let's bring it down further, 2 cos theta into sin theta divided by cos theta into sin theta. So if you see here, cos theta sin theta gets divided here, meaning is 2. Okay, so the answer for this question is 2. Okay, so the answer for this question is 2. So let me repeat what we have done. So we have converted this into the sine and theta. So remember, whenever you see this sort of questions where you have to be solving, okay, try to get it in a form which can be utilized. So we always try to put it in a format of sine and cos. Okay, so tan can be represented here, right? So one format we can use this sine and cos. So tan can be represented as sine divided by cos. So same thing, secant can be represented as reverse of cos theta. Okay, so cot we have represented as cos theta by sin theta. Then we have put cosecant theta in reverse of sin theta. So further simplifying, so we have seen that we can utilize, basically you have to make sure one of the formulas you need to utilize it to simplify. This is what is the main logic in the trigonometry. Okay, so how do we bring it simplify? We need to just be careful by looking at the question. Okay, so this sort of question comes, so just see that if you can simplify in terms of sine and cos, and further if you can utilize the formula to convert it its value. Okay, so that will help us in the resolution. So what we have seen here, so we simplified it, okay, and by putting the sine cos values. Okay, so converting into sine cos expression. Okay, further we simplified and we saw that, okay, it fits in one of the formula of cos theta, cos square theta plus sin square theta is equal to 1. So we replace and further simplifying gave us the solution. Okay, hope this is clear, students. Let's move to the next question. Okay, students, so we have the next sub question. Secant a plus tan a into 1 minus sin a. So as I've said in the previous question also, when you get this sort of questions, okay, and you need to have the conversion in terms of sine and cos. So let's proceed with the question and simplifying in terms of sine and cos. Okay, so second we have secant a plus tan a into 1 minus sin a. Okay, so this is how we need to solve it in trigonometry. Okay, try to see does it fit in first by looking at this, does it fit into the standard formulas what we have. Okay, the three formulas which we have discussed. If it doesn't fit, try to simplify it with the sine and cos. This is how we need to proceed. Okay, eventually we need to make sure it fits in one of the formulas to solve with the value. Okay, so let's now this doesn't fit in any of the three formulas which we have. So let's try to put it in terms of sine and cos value. Okay, simplify it in terms of sine. So we know secant a can be represented as inverse of or reverse of cos a. Okay, and we know tan can be represented in terms of sin a by cos a. Okay, then we have 1 minus sin a. Let's not. Okay, so put it in the simple. So because all this is in sine cos format. So this is clear, right? So we have converted, still the statement or expression remains same. So let's move further. So we can see that there is a common. So LCM we can take cos A. Cos A 1 plus sin A into 1 minus sin A. Okay, let's move further. Okay, so over here we can see that it is represented as this is the denominator. Okay, so this is represented as 1 here, right? So 1 plus sin A into 1 minus sin A divided by cos A. So can you relate this one? This is in the format of A plus B into A minus B. So A plus B into A minus B. So how can we write it in this? This we can write it in this format, A square minus B square. Okay. So let's write it here. 1 square minus A is here 1, B is sin A. So sin A, and we need to put the square here, divided by cos A. Okay. 1 minus sin square A divided by cos A. Okay, so now further can we simplify? No. Can we utilize that formula? Let's see your standard formula we have. Okay, so cos square A plus sin square A is equal to 1. So can we utilize this formula, which we can see in one of the three formulas which we have. So this formula can be utilized here. So let's put cos square A, bring this sign towards right side. 1, it becomes minus sin square A. Okay, because we have the denominator and we can utilize this value. So this is what we need to do here. So cos square A can be represented as 1 minus sin square A. So this we can represent it as cos square A. So let's substitute here cos square A divided by cos A. Okay, so sorry. So here square goes this, it becomes cos A. Okay, so do we have further simplification? No, so we can see it is asking in terms of the ratios. So we have cos A. So the answer is cos A. Okay, so let me repeat it here. So first thing is we try to bring it in one of the three formulas what we have. Okay, which is which can be utilized. Okay, so by looking at the question, we see that it's always better to convert it into sin and cos terms. Okay, so that we can utilize the formulas. Okay, and we went ahead, started resolving, and eventually we came to place where we can utilize the formula and put the value, and eventually we could get the value here. Okay, hope this is clear, students. Remember these three formulas which we have talked about and mentioned in our first question. Okay, so this will be keep repeating in terms of the exercises, especially for this. Okay, so in trigonometry it's all about finding a proper formula, replacing its value. Okay, so remember those formulas, and you need to make sure how you can express in that particular formula and replace that value. Okay, fine. So let's move to our next question, students. Okay, students, so in this next question we have 1 plus tan square A divided by 1 plus cot square A. Okay, so we need to see first, does it fit in any of the three formulas which we have discussed. So let me jot it down here once again. Cos square A plus sin square A is equal to 1. 1 plus tan square A is equal to secant square A. Okay, then we have cot square A plus 1 is equal to cosecant square A. Okay, so I'm just repeating here this. We have done this in the first question. So just remember this. So does it, the first thing we need to check is whether it can be substituted in this format. If not, then we need to convert it into sine cos format. Okay, so let's see whether we can put, yeah, so we can see here 1 plus tan square A can be represented as 1 plus tan square A. We have a formula, so this can be represented in this format. So let's try to replace here 1 plus tan square A into, okay, secant square A. Okay, then 1 plus cot square A. Do we have a formula for this? Yes, we have 1 plus cot square A. 1 plus cot square A or cot square A plus 1, both are same. So the value is cosecant square. So let's put the value here, cosecant square A. Can we further solve it? So does it fit in any of these formulas? We have utilized the formula here. Okay, this is the one which we can, right now we cannot utilize. So this thing is to convert whenever you are in this format, always try to go with the sine cos format. So we know how the secant can be represented. Secant can be represented as 1 by cos A. Okay, so we have a square here, so let's put the square here. Then cosecant square, so can it be converted in terms of sine cos? Yes, it can be represented. Cosecant is inverse of sine, so 1 by sine square A. Okay, okay, so this one, okay, so let's try to solve it. 1 by cos square A. So let's reverse this. So when it goes, sine goes up. Okay, multiply inverse sine square A divided by 1. Okay, so it becomes sine square, sine into 1 is sine square A. Okay, cos square into 1, it becomes cos square A. Okay, so we know sine by cos is nothing but tan. Okay, tan A, and we have a square here, so the answer is tan square A. So let's see whether we have, yeah, so we have the answer as tan square A. So hope this is clear, students. So I'll repeat it. So these three formulas which we have, try to put it in the form of one of the form, and then if it is still not further solvable, try to put it in sine cos form, and try to resolve that expression, and you will get the value. This is how the answers have been done for the trigonometry questions. Okay, we'll talk about something which is separate out here. Usually this strategy you adapt it. This will be helpful for solving. Okay, first find the formulas if it can fit in. Second, if it is not, then put it in the sine or cos terms. Okay, let's move to the next question, students. Okay, students, so let's read our question. Prove the following identities where the angles involved are acute angles for which the expressions are defined. Okay, so it's an acute angles, and this is the expression which has been given. So as I've said, so the moment you see, if you can see, you can put it in one of the formulas, express it in terms of one of the formulas. Can you put it? The three formulas what we have. So if not, then try to go for the converting in terms of sine and cos. So in this case we can see that, okay, cosecant square theta minus cosecant theta minus cot square theta. So here and the right hand side, if you see, this is what we need to prove here, right? So it is in terms of cos. So let's go ahead with the conversion in terms of sine and cos. So cosecant theta can be represented as 1 by sine theta. I hope you agree with this. Okay, then cot we know it is reverse of tan. Tan is nothing but sine theta by cos. Reverse of that, it becomes cos theta by sine theta. Then whole square. Okay, so we have this. So further what we can do, let's see the LCM is sin theta here. Sin theta 1 minus cos theta. Okay, whole square. So this becomes 1 minus cos theta whole square divided by sin square theta. Okay, so by looking at the right hand side, we can see that it is coming somewhere similar to what we are trying to get here. So 1 minus cos theta. So let's put this square in terms of like this. Can we represent this in terms of cos theta into 1 minus cos theta? Okay, so square root, put it in this. Okay, in this way, multiply, it becomes square. Okay, so we will not change the value here. Sin square theta. Okay, so let's see here further what it becomes. Okay, so we can put it here, and if you see here sin square theta, so can we further simplify it? Okay, can we use our formula, one of the formula from 3? Let's see. So we have cos square theta plus sin square theta is equal to 1. So if we put it in this format, it can help us to bring it based on the right hand side, right? So we can put sin square theta is equal to 1. Let's bring this here, becomes cos square theta. So if you put it, everything will become in one of the format. Okay, so let's put it here. Okay, 1 minus cos theta into 1 minus cos theta divided by, we can put it here, 1 minus cos square theta. Okay, fine. So further, if you want to simplify, we can use any of the formula. Okay, so we can utilize this. This can be represented as 1 can be represented as square here, right? So we can see a square minus b square, right? Which can be further written, which we have seen that it can be written as a minus b into a plus b, right? To simplify this, we can put it here, 1 minus cos theta into 1 minus cos theta divided by, so this is can be represented in this format. Okay, so students, you make a right side the working stuff whatever need to be written. Okay, so here due to the space I'm just writing here, so just make this as always in your sheets where you can proceed downwards. Okay, and make right side all our workings. Okay, so that we don't get much confused here. So let's try to put it in this. A square minus b square can be represented as a minus b into a plus b. Okay, so it can be represented as 1 plus cos theta into a plus b into a minus b here, 1 minus cos theta. Okay, so further looking at this, we can see that, okay, so there is 1 cos theta here, so this can be divided. Okay, so here if you see, we are almost getting near to a right hand side. Okay, so this is what, 1 minus cos theta divided by 1 plus cos theta. Okay, so from the left hand side we got the value. Okay, so here this is how we can represent. So sometimes when there is a left hand side and right hand side given, you need to convert. Sometimes you can bring it from right hand side to some conversion, and you need to bring it to a point where the left hand side is equal to the right hand side. So we have seen that cosecant, we went through from the cosecant theta minus cot theta whole square. Eventually, by resolving this, we came to the right hand side value. Okay, hope this is clear. So this sort of questions are need to be handled in this way. Okay, so sometimes you will see that the right hand side will not be straightforward, so that's also need to be converted so that both the left hand side and the right hand side coincides the solution. Okay. Hope student this is clear. Let's move to the next question. Okay student, let's solve this question. Cos A divided by 1 plus sin A plus 1 plus sin A divided by cos A. So we need to prove it is equal to 2 secant A. So one thing we said was we need to convert it in terms of cos and sin. Here we can see it's already converted into sin and cos. So is there a formula which we can apply here? So right now we cannot, but let's try to simplify it, okay, and sort it. So here it is given as in terms of, okay, so let's try to find the LCM here. Okay, let's see the LCM here. Let's solve it here by finding LCM so that eventually one of the formula which we can utilize out of the three, so which we have seen in previous questions. Okay, so let's go proceed. One thing is, if you can directly replace with the formula, apply it. If not, convert it into cos and sin format. Okay, so here in this case it's already in cos and sin format. Let's start to next step is, once we have this, we need to proceed further with solving. So here we are in the third place. First apply the formula, second convert into sin and cos format. Once you have this, try to solve it. So here we are already in the solution place resolving. So let's take an LCM here. Okay, so 1 plus sin A. Okay, so the LCM is taken like this. So common here. So here it is this one. So cos A will be there. So it will multiply it, cos A into cos A, cos square A plus. Okay, so this is 1 plus sin, cos is here, so this will get multiplied. 1 plus sin A whole square. Be careful, it's not sin square, it is this entire term whole square. Okay, so let's put it in this format. So here we can see it is in the 1 plus sin A. So can we utilize? So always we need to think, can we substitute it in any of the formulas or in identity? So here we cannot, but if we have a square, we can put it so with that formula. So here let's try to move here. Cos square A plus, so we can use this A plus B whole square is equal to A square plus B square plus 2AB. Okay, so the important thing in this trigonometry is try to express in one form or the other, so then you will get this relation. So here we have seen this is something represented in this, so let's try to put it in the form where we get, so here we can see cos square A, so we don't have sin square A, so by using this formula we can utilize it so that it can fit in one of our formulas. So there we have square. So let's see further how we can solve it out. Okay, so this becomes here 1 square plus B square is nothing but sin square A plus 2AB. Okay, so further down you cannot do much, so let's put it here. 1 plus sin A into cos A. Okay, so cos square A. So here if you can see, you can substitute this in our formula. What we have is cos square A plus sin square A is equal to 1. So at least this form that has come. So that's why we have substituted here, right? So we can put it in simplifying. Cos square A plus sin square A can be represented as 1. So 1 plus what is remaining, 1 square is 1 plus 2 sin A. So 2 sin A, 2 sin A divided by 1 plus sin A into cos A. Okay, so 1 plus 1 is 2. 2 plus 2 sin A divided by 1 plus sin A into cos A. Okay, so further can we simplify plus sin A? Okay, so if you bring 2 here, see here what happens. 1 plus sin A Okay, so down we have 1 plus sin A into cos A. Okay, so here we know this gets cancelled. Okay, we have 2 top cos A. Okay, so does our answer has any of this? Okay, so we need to bring it, so we have almost there. So 2 of secant A. Okay, so we know what is secant. Okay, secant is nothing but inverse of secant A is nothing but inverse of cos A. So we can put it as 2 secant A. So this is how we have solved this. Okay, so just remember one of the 3 formulas which we have. If you can represent it, put it there. Secondly, put it in sine cos format. Thirdly, start substituting the values and try to solve and see where we can represent it, wherever we could represent with simplification to a formula so that its value can be put in. Okay, that's how we can proceed to solve this sort of trigonometry questions. Hope this is clear, students. Let's move to the next question. Okay, students, we have a question here in terms of tan and cot. Okay, so as I mentioned that whenever you see, try to put a formula if you can. If not, convert it into a format which can be a format of sine and cos, which can be expressed and further resolved. Okay, so let's proceed. Let's convert into our question sine and cos. Tan theta divided by 1 minus cot theta plus of cot theta divided by 1 minus tan theta. Okay, this is the left hand side. So let's try to convert in sine cos format. So tan can be represented as sin theta divided by cos theta. Okay, so further 1 minus cot. Okay, so cot can be represented as cos theta divided by sin theta. Okay, so just be careful with the signs here and also the simplification. So cot can be represented as cos theta divided by sin theta. Okay, so we have 1 minus tan. Tan can be written as sin theta by cos theta. I hope till here we're clear. We've just done the conversion from to sine and cos format. Okay, so let's move forward. This is becoming a little bit confusing, but it's straightforward. Only thing we need to do some simplifications here. Okay, so sine and cos, sine theta divided by cos theta. Then we have further, so we can take the LCM. LCM is sin theta. Okay, so it becomes sin theta minus of cos theta. Okay, plus let's keep this here same, cos theta divided by sin theta. If you can see, all are expressed in terms of sin and cos. So let's take the LCM. Cos theta. Okay, cos theta minus sin theta. Okay, so till now we've just done the simple simplification. Okay, so here, so reciprocal is this, so let's try to simplify further. So down, if you it will up, if it goes, it becomes reverse. So let's try to simplify further. Sin theta divided by cos theta into this sign, it gets reverse. Okay, so it becomes up sin theta, this comes down. sin theta minus of cos theta. Okay, plus same thing let's try to do here, cos theta divided by sin theta. So if you bring it up, it becomes reverse. So it becomes cos theta divided by cos theta minus sin theta. Okay, so further simplifying, what do we get? So sin into sin becomes sin square theta. Okay, so here if you can see common is cos, let's bring the cos outside, common cos theta, it becomes, remaining is sin theta minus cos theta. So here there is a multiplication sign, not the plus sign, so be careful here. Okay, so plus of cos into cos becomes cos square theta divided by sin theta into cos theta minus sin theta. Okay, so further we can simplify sin square theta. Was anything cancel? No. Okay, so LCM. Okay, so if you want to take in LCM, it should be okay. So here it can be. Okay, so inside this we can see there is a common here. Okay, sin theta minus cos theta minus sin theta. Okay, so we can convert into one of the form. So this cos theta minus sin theta. Okay, so can this be converted into this format? Yes, it can be. How? So minus sin theta plus cos theta. Okay, so now if we bring minus 1 outside, it becomes sin theta minus into plus becomes minus cos theta. So we are doing this just to make sure one to find the LCM. Okay, so we can put the common here, this, so that it simplifies. So that's why we put here. So we can put this here. Okay, so let's try to replace here, sin square theta divided by cos theta into sin theta minus cos theta. Okay, so we have put here. So if we reverse this minus. Okay, so let's put it here, cos square theta divided by sin theta into minus 1. Okay, so into sin theta minus cos theta. This is multiplication, so this can be plus into minus, so it becomes whole. So let's bring it here. So minus sign will come here, sin square theta divided by cos theta into sin theta minus cos theta. So it's a multiplication, so minus sign becomes here, minus into plus becomes minus here, minus cos square theta divided by sin theta into sin theta minus cos theta. I hope this step is clear to you. So we have just made it similar. So to make it similar, we need to multiply here with minus 1. Okay, this minus 1 here is there. So we have plus and minus. So it becomes minus. So multiplication, if we do, it becomes minus. So let's now take the LCM. So what will be the LCM here? It will be cos theta, and you have sin theta. Okay, then you have sin theta minus of cos theta. Okay, so I hope this is clear, student. This is the common here we have, right? So let's bring that. Okay, common here in this. Then what is remaining? Cos theta and sin theta. Okay, so now we know here we have cos sin theta. So what is remaining is sin theta. So sin theta we need to multiply here on the top. So already we have a sine. So sine square into another sine, it becomes sine cube theta minus, okay, what is remaining here? Sin theta, sine is there, cos theta. So we need to multiply with cos on top. So cos square is already there. Cos square into cos becomes cos cube theta. Okay. So let's further resolve this. To further resolve it, we need to have one of this conversion. So here we can see this can be represented in terms of a cube minus b cube. It can be seen as this identity. So with this we can do this conversion. Okay, a minus b into a square plus b square plus ab. So in this format we can convert it. Okay, so a is sine here, b is cos here. Okay, so let's put it in this format. Sine theta minus cos theta. Okay, then we have, so a is sine square theta plus b is cos square theta plus of sine into cos, sine theta into cos theta. Let's put our LCM. Sine theta denominator here, sine theta into sine theta minus cos theta. Okay, so we went to this format to solve it further, so that we can get the next step. Otherwise we need to move on. So we need to keep moving further, simplifying in this trigonometric expressions. Okay, so how we can resolve further? So we can use this identity. Okay, and utilizing this identity, we got in one of this format, which we can see here. It's getting here in the denominator is there. Okay, and on the top also we have. So what we can do is we can get cancel this. Okay, so let's see what it becomes. Okay, so here if you can see one more thing, you can utilize this sin square theta plus cos square theta is equal to one formula. So we can put this 1 plus sin theta into cos theta divided by cos theta into sin theta. Okay, so can we further simplify? So let's look at our right hand side. Okay, so it says that it should be in secant and cosecant format. Okay, so further we need to solve this. Okay, so how we can solve it? Okay, so here we can see something common here, so let's further solve it here. So we took the LCM, now we'll do the reverse of it. Okay, so 1 by, it can be represented as 1 by cos theta into sin theta plus of sin theta into cos theta sin theta. Okay, so cos theta into sin theta is nothing but sin theta into cos theta. It can be interchangeable. So this gets cancelled. So this becomes 1 by cos theta into sin theta plus of 1. Okay, so we have seen that the question, the right hand side was being represented something similar to here. So 1 plus secant theta into cosecant theta. So now when we are doing the simplification, we convert into sin and cos. So reverse will do now. Okay, so 1 by cos theta. Okay, so here we are going to represent this. Okay, so we know 1 upon cos theta is secant theta. Okay, so secant theta, 1 upon sin theta, okay, is cosec theta. Cosec theta. Okay, so 1 upon, okay. So this we got it. Then we have remaining plus 1. So is this our answer? 1 plus secant theta into cosecant theta. So this is the right hand side. Hope this is clear, students. So we put it in 1 plus secant theta into cosecant theta. Okay, so here, as we said, try to put it the formula. If not, if you can straight away put the formula, try to resolve that. If not, then try to get it in the sine and cos theta format. Okay, and keep solving further using the expressions what we received. Okay, as part of this, and try to meet up till the right hand side given. Okay, let's move to the next question, students. Okay, so let's read here 1 plus secant a divided by secant a is equal to sine square a divided by 1 minus cos a. Okay, so hint is given as LHS and right hand side. LHS separately, simplify. Okay, so here what we say is that whenever we get either we need to put it in the formula. Okay, if it fits in, so one of the formulas, 3 formula we have, it doesn't fit, so then we do is simplify with put it in the sine and cos format. So let's start with this, converting into sine and cos format. 1 plus secant can be represented as cos e, right? Okay, so 1 divided by cos e. Okay, so let's take the LCM cos a. So here it will be cos a plus 1 for the secant t is cos a. So here if you see here cos a gets divided, so the answer is cos a plus 1. Okay, so further can we solve it? No. So in this sort of situations, what we'll do is we'll bring our right hand side to equivalent of this to prove it. Okay, so let's go ahead. What is the right hand side? Sine square from right hand side. Sine square e divided by 1 minus cos e. Okay, so sine square a in terms of cos, so we know we can utilize our formula sine square a plus cos square a is equal to 1. So we can put sine square, represent sine square in terms of this 1 minus cos square a, so that we can relate it here. Okay, so let's put it in this way. 1 minus cos square a. So we are replacing sine square a with this. Then 1 minus cos a. Okay. So further, so here we can see that there is a square, and if it happens to be the square, we can utilize this formula identity a square minus b square is equal to a plus b into a minus b. So that way it gets cancelled. So we can utilize. So 1 square you can make it. Okay, so 1 square is nothing but 1, so it doesn't change. So we can replace here in this format. So a is 1 plus b is cos a into a minus b. 1 minus cos a. This is divided to 1 minus cos a. So if you can see 1 minus cos a, 1 minus cos a gets cancelled, and we have seen 1 plus cos a is remaining. Okay, so this is similar to 1 plus cos a. So from this left hand side is equal to right hand side, hence proof. Okay, so hope this is clear, students. So sometimes if you're further not able to solve, you have to take from the right hand side and try to equate it, bring it to a term or a place where the left hand side resolution is equal to the right hand side. Okay, with these clear, students, let's move to the next question. Okay, students, let's read the next question. Cosecant A minus sin A plus 1 divided by cos A sin A minus 1. So first we need to see whether we can put in any of the formulas. Okay, which we have three formulas out of that. Okay, so second thing is simplifying by dividing and sine and cos. Okay, third thing is for simplifying the given question. So here we can go with the simplification, and here using the identity cosecant square A is equal to 1 plus cot square A. So here we can see that it says that we need to utilize this identity. So cot. So what is cot? Cot is nothing but cos by sine, and cosec is reverse of sine. So what we can do is here, by looking at this left hand side and right hand side, what we can do is we can divide the left hand side with the sine. Let's see how we can move forward. So the reason why we are dividing is to form cos divided by sine will become cot. So we can see some of the identities here, cot, okay, and cosecant. So we can let's divide it by sine and proceed with the solution. Okay, divide each term by sine A. Okay, so cos A divided by sine A minus sine A divided by sine A plus 1 divided by sine A. Okay, so both the sides, numerator and denominator, if we divide with same, the equations remain the same. Okay, so let's divide the denominator. Cos A divided by sine A plus of sine A divided by sine A divided by sine A minus of 1 divided by sine A. Okay, so here we can see sine A gets cancelled, it becomes 1. Here also sine A gets cancelled. Okay, so let's further simplify it. Cos A by sine, we know it is cot A. Okay, then minus what is remaining here, 1 plus reverse of sine A is cosecant. Okay, so cos by sine is cot plus of this becomes 1 minus of cosecant A. So why we went ahead with division? So that we can get in one of the forms which has been given here. So right hand side also we can see cosec, cot, okay, and the identity is also given. So that's why we need to we will be dividing here by sine A. So both the numerator and denominator, if we divide, the value in the expression doesn't change. So let's move forward. Let's further simplification. Okay, so here for the simplification, it should be in terms of the information which is given. So it says using the identity. So can we utilize this identity? Cosecant square A is equal to 1 plus cot square. So here we can see that it is coming in this form. So we can utilize utilize this. Okay, so further simplifying, we'll get this. Okay, cot A, this cosecant we know, cosec A, then minus of 1. So this 1 value we can use this identity given. So let's see how we can utilize this identity. Cosecant square of A is equal to 1 plus cot square A. So if I bring 1 this side, it becomes 1 of, okay, so this side if you bring the cot, it becomes, okay, so cosecant square A, this becomes minus of A. So 1 we can replace here with this cot square A. Okay, so let's see further if we can simplify with this value. Okay, so 1, let's replace with the value which we have received. Minus sign is there. 1 we will replace with cosecant square A minus cot square A. Cot of A plus 1 minus cosecant A. So now further simplifying, we'll get cot of A plus cosecant of A minus. So if you see here down, there is a term which we can correlate. So this can be represented in the form of A square minus B square. So we can put it in this form, A plus B into A minus B, so that we can divide with the denominator. Okay, so minus sign will be there. A is cosecant of A minus of, sorry, plus of cot A plus B over A minus B. Cosecant of A minus cot of A. Further denominator, cot of A plus 1 minus cosecant of A. Okay, so here if you can see cot of A plus cosecant of A. Cosecant of A plus cot of A is nothing but interchangeable, cot A, cosecant A. So this can be taken as a common. Okay, so let's take common here, cot A plus cosecant of A. Okay, then this is the common which we have taken outside. So this expression, if we take, this becomes 1 minus of. Okay, so let's further simplify it. Okay, so 1 minus, okay, this becomes 1 minus of, this is common which we have taken outside, so this becomes cosecant of A, so let's put a bracket, minus of cot A. Divided by cot of A plus 1 minus cosecant of A. Further simplifying, cot of A plus cosecant of A into this bracket minus minus to minus, this becomes cosecant of A minus into plus becomes minus into minus becomes plus cot of A. Okay, so let's move forward. So numerator is done, denominator will write cot of A plus 1 minus cosecant of A. Can this be further simplified? Okay, let's see. Okay, 1 minus cosecant A plus cot A. So we can see 1 minus cosecant A plus cot A. So this, okay, so this can be, okay, this is similar. Okay, so numerator and denominator we have same. This 1 minus cosecant A plus cot A. So 1 minus cosecant A plus cot A. So we can divide this. So remaining will be cot A plus cosecant of A. So this is the one which we were looking for the right hand side. Cosecant of A plus cot A. Cosecant of A plus cot A. Hope this is clear, students. Okay, let's see what we have done here. We have seen that by looking at the left hand side, we are getting in the form of a cot and cosecant. So what is cot? Cot is nothing but the cos and sine. Cos divided by sine. Cosec is reverse of sine. Okay, so for that what we can do is we can we cannot put the formula here. For that we need further steps, further simplifications. So what we did was we divided by sine here. So this gives us again that cos by sine, okay, which will be cot. So further we can utilize it. Okay, and one point we came across here by simplifying and substituted the identities, and by resolving the identities we got this value, cot A plus cosecant A. So remember, in trigonometry, as I have been saying this, that you need to find first how you can replace the formulas. You can identify which formula out of the three can be put in to resolve it. If not, you need to put it, divide by sine and cos, so that we can get further simplification. Here we got already in the divided format, but it is not in the sine cos format it is. So we need to form this in the given expression. So we went ahead with the division of sine A, then further solving this has resolved it. So just remember the formulas. First thing, replace if you can with the formula. If not, simplify by dividing sine and cos, sine and cos. Third thing, resolve the solution, the equation which you have got by putting the right identity. Okay, so that's how we can solve this sort of questions in trigonometry. Hope this is clear, student. I know it is becoming a little bit difficult to analyze. The reason is, this is what is the strategy with regard. So here, if in trigonometry, you need to know the formula and you have to keep simplifying. And when left hand side and right hand side is given, so you need to see how you can correlate it by going one step. Before doing one step, you need to analyze, okay, how can I get this value? For example, cot is what? Sine, cos by sine. So that's how you can identify. And if any information is given identity, so you can see how you can replace those identities in the given question. Okay, hope this will help you. Let's move to the next question. Okay, students, let's move to the next question. Okay, so here you have in the form of a root 1 plus sin A divided by 1 minus sin A is equal to sec A plus tan A. Okay, so here whenever you get in this form, try to simplify it by removing how you can remove the root. Okay, so by rationalizing, so how you can get it. So and also if you see here, you have a tan, so that means somewhere down the line we will be utilizing our identity formula to get this values. So now first thing is, when you see this sort of root, try to simplify by multiplying both the sides, okay, numerator and denominator, so that the you get try to get out of this root. Okay, let's see how we go. One plus sin A divided by 1 minus sin A. Okay. plus sine A divided by 1 minus sine A. Okay, so you can multiply here with 1 plus sine A divided by 1 plus sine A. This, so if you divide it, it goes away. Okay, so the value remains same. So to simplify, we are multiplying here. Okay, let's do further step. Okay, so let's solve first inside the root. Okay, then we'll put the root here. So this becomes square. Okay, so 1 plus sine A whole square divided by so here you can see this is forming like A minus B into A plus B. So we can utilize this A minus B into A plus B identity as A square minus B square. So let's try to put it here. A is here 1 square minus B is your sine square A. Okay, let's not forget our root. Okay, so further solving we can utilize this, right? Plus sine A square divided by, so this we can utilize our identity. What is it? Sine square A plus cos square A is equal to 1. So can we put it in this? Sine square A. Let's bring this 1 inside, becomes minus 1. Then this no, so here it is 1 minus square. So let's do in this way. So let's put it in 1 minus square, right? So 1 is here. Okay, then let's bring this sign. Okay, so let's bring this. Okay, what is this? 1 minus format. Okay, so 1 minus sine square A. So remaining will be cos square A. So if I bring it here, it becomes minus. So I can utilize this identity. Yes, I can utilize this identity. So here I can say 1 minus sine square. There is also nothing but 1 minus sine square. 1 square is nothing but 1. So I can put it as cos square, so that I can remove this root here. Okay, so that's the reason we utilize this identity. So let's bifurcate this. The root is at the top also. There is a root 1 plus sine whole square divided by root of cos square A. Okay, so now we have at least removed from the denominator the root. So let's see how we can further solve it. Okay, so here I need to check it out. Okay, so let's read our question here. Sin theta minus 2 sin cube theta, 2 cos cube theta minus cos theta is equal to tan theta. So here can we put our identity? No, we don't have identity with the cube, so we have with square. So let's bring this to a square format. Okay, sin square. Okay, so we can utilize our identity sin square theta plus cos square theta is equal to 1. Okay, other than that I don't see any identity we can utilize, any of the formula we can utilize. So let's go ahead and start with this. Okay, so here, so common we can take to make it square. Okay, so let's bring this sin theta outside. So what will be left? 1 minus 2, 1 sine we have taken, so it will be sine square theta. Okay, so similarly here we have cos, so let's bring the cos outside, cos theta, it becomes 2 cos square theta minus 1. Okay, so here sine theta we have. Okay, so sine square theta 1 we have. So we know what is the value of identity we can utilize. Let's see, sine square theta plus cos square theta is equal to 1. So if we try to utilize this identity, can we? Okay, so 1 is there, so we can put the value and that gets reduced. So, okay, so similarly can be done here. Okay, so let's simplify further. Sine theta, so 1 will replace with the formula sine square theta plus cos square theta, this minus 2 sine square theta, so that we can further simplify. Okay, so we have cos theta outside, 2 cos square theta minus. Similarly we can do, so here it will get cancelled here. Okay, subtracted. So let's put minus 1 instead of 1. Minus sign is here, 1, we'll put it as sine square theta plus cos square theta. Okay, so here, okay, let's further simplify. Sine theta is equal to, here we can see sine square theta minus 2 sine square theta, it becomes sine is bigger, minus sine square theta plus cos square theta. Okay, so further cos theta is equal to, okay, so 2, here we have cos, so minus into plus becomes minus, so this becomes minus into plus becomes minus, so it's a minus cos theta, so it can be subtracted, yes. So 2 minus 1 becomes 1, cos square theta minus into plus becomes minus sine square theta. So I've just skipped one step, simplified it. Okay, minus sine theta minus sine square theta plus minus cos square theta becomes, so that has been 2 and 1 is there, so it get subtracted. Okay, so the sine theta cos theta, so we are nearby. Okay, so the question says that can be further, yeah. Okay, so here if you see here cos square theta minus sine square theta, cos square theta minus sine square theta, so if you write it in this format, theta is equal to the bracket itself, cos is cos square theta, this minus comes this side, it becomes sine square theta. Nothing much I have done, so I've just replaced the position within the bracket so that I can correlate here and try to divide it. Okay, so at the denominator we have cos square theta minus of sine square theta. Okay, so this helps us, this gets divided, remaining is sine by cos, sine by cos, we know it is tan theta. Okay, so this is what is the expected tan theta. Okay, fine students. So first thing what we saw in this question is it is in the form of a cube, so we know there is no formula which we can utilize in terms of cube, so we simplify in terms of square. How do we simplify? So we brought one common outside. Okay, same thing at the numerator and denominator. So further solving, step by step we got this identity. Okay, and finally we could get our right hand side. Okay, now this question is clear, student. Let's move to our next question. Okay, so let's read our next question here. Sine A plus cosecant A square plus cos A plus secant A square is equal to 7. Okay, so left hand side is this, right hand side is coming in form of tan and cot. Okay, so we have, can we simplify, can we put up formulas here? Okay, so here there is a square, so first we need to simplify the squares. Okay, so that we can put a formula, then we will see further. Okay, if required we need to divide by sin and cos. This is our strategy. So first try to put, if we can put any of the formulas and replace the values. Second, after that, if you can't, then second thing will, if you can, or if you can't, then move to the next step is by dividing by sin and cos. Okay, then third, simplifying the LCMs. Okay, usually we get in the LCM format, so simplifying that. Okay, so let's proceed. First thing is, here it is a square, so we need to see how we can get. So we can utilize our formula of a plus b whole square is equal to a square plus b square plus 2ab. Okay, so let's put it here, easier side. Okay, sin square a plus cosecant square a plus 2, okay, sin a into cosecant a. Okay, then plus, same thing here will apply since plus, so not to worry. Okay, so a square is cos square a plus secant square a. Okay, so here let's erase this, we know this, so let's erase this for the time being. Okay, so a square plus b square plus 2 is cos a, b is secant a. Okay, so here further what we can do, can we now it is out of the square. Okay, so can we utilize the identity? Yeah, we can utilize the identity sin square theta plus cos square theta. So we can utilize this. This becomes sin square theta plus cos square theta is equal to 1. Okay. Okay, so can we utilize, so we utilize the formula sin square theta plus cos square theta is equal to 1. Okay, so can we utilize the other? Okay, 1 plus tan square theta is equal to secant square theta. Okay, so here we have secant square, so we can replace here. Let's see further. There is one more. Okay, so cosecant is there, so can cosecant is written as 1 plus cot square theta is equal to cosecant square theta. Okay, so here we, let's first put it in the form so that we don't get confused here. Okay, so we have this sin square a, we took it, then we have this cos, where is it? So here we put plus cos square a plus what is remaining, so remaining is cosecant. Okay, so cosecant square a plus, okay, what is singular here? Okay, so we have secant, so this is done, so this is the one, secant square a plus, so this is remaining plus 2 sin a cosecant a plus what is remaining from this is the one. Okay, so 2 cos a secant a. Okay, so here we know its value is 1. Okay, plus, so cosecant square we can utilize this. Okay, so we have some value, so let's put it here, cosecant value as this. Okay, so 1 plus cot square a plus, this is done, secant square, so secant square also can be represented in the 1 plus tan square Okay, so we can see that we are getting something similar, cot and tan. So right hand side we are trying to relate it by putting this. Okay, so 1 plus tan square theta. Sorry, tan square a. What is remaining? Okay, these are the ones which are remaining. 2 sin a. Okay, so cosec we know it is nothing but the reverse of sin a. Okay, plus 2. Okay, let me erase this. 2 cos a. So secant can be written as, we know it can be written as 1 by cos a. Okay, so that we can come nearby to the right hand side. Okay, so let's simplify. Sin a get cancelled, cos a get cancelled. Okay, so let's try to simplify further. We have 1 plus 1 2, then we have 3, then we have this is cancelled, 3 plus 2. Okay, let's put it further, simplify. 1 plus 1 plus cot square a plus 1 plus tan square a plus remaining is, this is cancelled, 2 plus the remaining is 2. Okay, so here 1 2 3 4 5 6 7. Okay, plus we've got the digits here. So now 1. Okay, cot, what is remaining? Cot square a plus this is done, tan square a. This is done, this is done. So as per the right hand side, we have 7 plus we have tan square. Yes, tan square we have tan square a plus cot square a. Okay, so cot square a. Hence this is proved. So here what we did was, we want to simplify, but we have it in a square root format. There is no such formula, so we simplified it by our formula. Okay, a plus b whole square. Then once we simplified, we saw that if we can utilize any of our formulas, yes, we utilized it. And also we saw that the reverse identities are there. So something like a into 1 divided by a. So we took this identity, sin a and cosec we converted into 1 by sin a, so that get cancelled. Same thing we did it with the cos and secant. So simplifying this, we got the values, and further adding this, we saw that we have reached to the RHS. Hence this is proved. Hope this question is clear, students. Let's move to the next question. Okay, students, let's read our next question. Cosecant a minus sin a into secant a minus cos a. Okay, so is equal to 1 by tan a plus cot a. Okay, so as I have been saying that whenever you see this format, try to convert in the by dividing sin and cos. So this is one thing. So first thing is, try to see if you can put one of the formulas. If not, try to simplify by dividing it. Okay, and then again see. So keep repeating this 3 steps. One thing is, try to put the formula. If not, divide it by sin and cos. If not, simplify further. So once you simplify, either you will get somewhere towards replacing with the formula, or you can try to divide it by sin and cos. So this is the one which trick need to be used for solving the trigonometry questions. Okay, so here let's see. Okay, so here we know how the cosec can be written in the form of 1 by sin a minus sin a. Okay, so secant can be written in the form of cos 1 by cos a minus cos a. This is from the left hand side. Okay, so next up what we have is simplifying. Okay, so we have the LCM here, sin A. Sin A, so sin A remains here, minus of sin to sin becomes sin is, sorry, I did a mistake here. So here is the sin, so sin is already there, right? So it becomes, remains the same, 1 minus, we need to multiply this sin with this, so it becomes sin square A. Okay, so same thing here, cos A, so 1 remains, so cos into cos, cos square A. Okay, so can we utilize the identity further solving? So let's see, our first identity or the first formula we can utilize, sin square theta plus cos square theta is equal to 1. Okay, does it fit here? So sin, so if I bring here cos square theta 1, this if I bring it, it becomes minus sin square theta. Okay, so let's bring it here. So I can write this as cos square theta. Cos square theta divided by sin into A. Okay. Can the similar here be applied? So I can write sin square theta is equal to 1. So sin square theta is there, is equal to 1 is there. So this I'll bring it this side, it becomes minus cos square theta. Okay. So I can write it as sin square theta divided by cos A. Okay. So here if you can see, you can divide it here. Okay. So once this goes, once this goes. So numerator is 1 here, so it becomes cos theta into sin theta. So nothing is remaining down. Okay, so can you further simplify cos theta, sin theta? No, so you cannot use the identity. You cannot use cosine, you've already done division. Can you further simplify? No. So let's see what is the next step here. Okay, so we have seen the left hand side has come towards this. Further simplification is not this. So what we can do is, one of the thing is, we need to bring our right hand side. Okay, and try to simplify. And if we can see if we can equate it here. So let's see. So this is how in the trigonometry you need to solve. Okay, so we have come to a place where it cannot be further simplified, right? So we need to equate left hand side is equal to right hand side. So let's take this 1 by tan A plus cot A. Okay, so what we do usually, we just divide it by sin and cos to get it. So can this be further simplified? Yes. So tan can be written in the form of sin A by cos A plus cot can be written in terms of sin A by cos A. Okay. So 1 remains here. So there is an LCM here. Oh, so tan and cot cannot be, right? So what did I do here? I did a mistake here. Okay. So it is cos A by sin A. Okay. So LCM is cos A into sin A. Fine. So here cos is there, so sin. So it becomes sin square A plus, so cos is here, so sin. So cos is the LCM, sin becomes cos square A. Okay, so this is something similar to 1 by x divided by 1x y by 1. Okay, so if you reverse, it becomes 1 by x into 1 by y. Oh, 1 second. Okay, so before doing this, we can see here we can further simplify it. Okay, so let's try to simplify it here. So 1 divided by sin square theta plus cos square theta, we know it is 1. Okay, so divided by cos A into sin A. Okay, so if we bring it reverse, this goes at the top. Okay, so 1 into cos A into sin A. Okay, so 1 will cancel, so we will get cos of A into sin of A. So which is the one which we've got here. So left hand side is equal to right hand side. So hence proved. Okay, so one thing we need to we have done similar in previous questions as well. So formula, first thing is putting the formula, simplifying, and you need to find the identities so that you can further simplify it. Okay, so try to put your formula, and first thing usually what I've seen is if you try to put substitute the formula if it can be, so that is the first thing you see. Second thing you see is that whether you can divide the sine and cos so that your if right hand side is given it can correlate. Okay, usually put it this way even if it is not given, so try to put it in dividing by the sine by cos so that it can, so then simplify it. So this can be keep repeating till you get a further solution. So now when you reach some point where your left hand side reaches some point and there is a right hand side given, so in that case what you can do is you can derive one step from the right hand side so that you can relate your left hand side and right hand side. Okay, so this is the accepted way of solving the trigonometry. Okay friends, let's move to the next question. Okay, so let's see our question here. 1 plus tan square A divided by 1 plus cot square A is equal to 1 minus tan divided by 1 minus cot power whole square is equal to tan square A. Okay, so one thing here is as I say, first thing is if you see whether you can put out of these three formulas which you see from this starting from the first question can be replaced. So here sine square cos square theta is not there, so we cannot. So there is another formula which we use. Okay, so secant, we can put secant square A is equal to 1 plus tan square A. So this is one. Okay, and we have another related to cosecant square A is equal to 1 plus cot square A. Okay, so here it is given this way, so we can straight away put for this. Okay, so we can write the LHS in this form. 1 plus tan square can be written as secant square A divided by cosecant square A. Okay, so first thing we have done is replace the formula. So does it solve our problem? So we have seen that there is a right hand side coming in the tan form, and usually the next step what we say is divide it by sin and cos so that we can get it, convert it or divide, get it in the form of sin and cos basically. So can the secant be written? Okay, yeah, secant is nothing but 1 of cos square, reverse of cos square A. Okay, so cosecant also can be written in terms of reverse of sin square A. Okay, so here, so if you reverse it, this goes at the top, so it becomes, this will go at the top. Okay, so this will go here, so this gets multiplied, so 1 into sin square A, so this 1 into cos square A becomes cos square A. Okay, So here we have sine by cos is nothing but tan square A. Okay, so here we have got the proved first equation is equal to here is equal to tan square. So let's try to use the second equation and solve it. Okay, 1 minus tan A divided by 1 minus cot A power whole square. Okay, so here let's further. Okay, so it is given. So let's first convert this into one format so that we get into tan. So cot is opposite of reverse of tan. So let's put it in that format. 1 minus tan A divided by 1 minus cot can be written as 1 by tan A. Okay, so don't forget to put the square here. Okay, so here further, okay, let me just write the space here. So top remains same, 1 minus tan A divided by LCM will take, okay, tan A. So here it becomes tan A minus tan is already 1, okay, so whole square. Okay, let's go further down the page. So here we can do, yes, we can see here there's a pattern, tan minus 1, 1 minus tan. So if minus comes out, this can be subtracted. Okay, so let's bring it in that. So 1 minus tan A, okay, divided by, so let's bring the minus outside. 1 minus into plus becomes minus into minus becomes plus tan A, okay, divided by tan A whole square. So 1 divided by x, 1 divided by x, okay, divided by y divided by z. So let's put it here. So this goes in the, this gets cancelled. Okay, before cancelling, let's bring it up. Okay, so 1 minus tan A, okay, this one. So this becomes reverse of it. So down, this goes on the top. So tan A divided by, this remains minus of 1 by tan A. I know this is a little bit confusing which I'm writing, so please bear with me. So minus is there, so let's bring this minus, square, right? So let's keep it here. So minus is there, so this gets cancelled. So this becomes minus of tan A, so whole power whole square. So square means minus gets into plus, minus becomes plus. So it is nothing but tan square A. Okay, so I've seen tan square A, hence with the second as well, we have proved tan square A. Okay, students, hope this is clear. So here we went ahead in terms of converting into sine and cos, but to convert this into sine and cos, okay, so first we saw the identities, the formulas which we can utilize. Okay, so that itself solved one of our queries. So then we saw that it can be converted into sine and cos. We went ahead, instead of first going the conversion into sine and cos format, we could see that the formula itself can be fitted to replace here. Okay, so the sequence doesn't matter here. So either you can see the first thing is if you apply the formula, the steps will be lesser. Okay, so wherever you can apply, so you can put it in this way. First try to see the formulas where you can apply, then you can see whether you can divide by sine and cos, or you can do simplification and keep continuing this. So see, keep checking, can you apply the identity, and also see that whether your when right hand side is given, so can you correlate that by any of your identity and the simplification. So that's something which you need to keep in mind when you're solving the trigonometry. That is a trick of the trigonometry problems. Okay students, let's move to, okay, so I hope this is the last question which we have. So let me reiterate here. So as I've said, so for this exercise, especially for the trigonometry, three formulas which you need to remember. So one is sine square theta plus cos square theta is equal to 1. Here you have the secant square, a is equal to 1 plus tan square theta, cosec square theta plus 1 plus cot square theta. So this is the one, and you need to know what is the reverse of sine, what is the reverse of cos, what is tan, sine by cot. The reason is you want to replace and come to a simplification in terms of sine and cos. So remember these formulas when you're solving the trigonometry questions. First see that whether you can put these formulas. Next step is to see if you can simplify with the dividing and multiplying with the sine and cos format. Okay, and also see whether we can the right hand side, if it is given, how far we can relate it to it. Okay, so those formulas, can you apply it, whether if you put this particular formula, whether you'll get the value towards the right hand side. Okay, so just keep an eye towards the right hand side. Are you coming nearby with your resolution, resolving from the left hand side when you're resolving, simplifying? You will have a look onto the right hand side. Are you going in the right direction? Some questions we have seen that it cannot be simplified further, so that time we can use the right hand side and simplify that and come to a conclusion where your language is further cannot be simplified. We can at least equivalent to that. So that is the expected resolution for the questions of this sort in the trigonometry chapter. Hope this chapter is clear, students. I know I have been saying about the formula and all these things. It's I understand this is the first time you guys are doing, so this requires a lot of practice. And believe me, it is quite simple if you know the formula and you know how to simplify. So remember the formula for the trigonometry, how you can convert it from the one form to another form, that is from sine to how you can sine, cos you have, then you have tan, you have cot. So you can see, you need to know how this has been converted. Okay, so this are the crux summary to resolve the trigonometry. This can be easily scored if you know these things, but you need to know, practice it, and always see the right hand side if it is given. Okay, so that can help you to come to a conclusion. But maybe if you try certain number of questions related to trigonometry, all will be following in this. So the appearance of the question looks bigger, but it is really a very easy way to solve it by following these steps which I have mentioned. Hope I have not repeated multiple times. So the reason why I am emphasizing is so that you understand that this is not difficult. Okay, this is simple to resolve it. Only thing is with this particular trick you can resolve it. Okay students, with this we will end the exercise related to 8.3. Thank you very much. Hope you like it. If there are some inputs which you would like to provide or the feedback, please comment it out. Thank you. I'll get back to you on this detail. Thank you very much. Take care. Bye.